41. 41 fully funded PhD positions in space science at a university partnered with CERN, the European Space Agency, and the Italian Space Agency. Working on black holes, antimatter, gravitational waves, lunar rovers, space nutrition, even space law. No tuition fee, a stipend of over 18,000 euros a year, open to absolutely any nationality, and 5 seats specifically reserved for Kenyan citizens. This is the National Doctorate in Space Science and Technology at the University of Trento, Italy. The deadline for this opportunity is July 20th, 2026. So welcome back to my channel, Scholarship, where we find fully funded opportunities so you don't have to subscribe right now, because what I'm about to show you is generally one of the most impressive PhD programs that I've come across. Okay, talking first, let me explain you why this program exists and why it is such a big deal when it comes to the type of PhD which I'm basically talking about. So Italy has a long tradition in space science and technology, and in recent years, Italian public investment in space has increased significantly, partly through Italy's National Recovery and Resilience Plan, which is investigating heavily in the space sector. In this context, Italy's Ministry of University and Research and the Italian Space Agency launched a national initiative developed Foundation of Space Science and Technology, and one result of that initiative is this PhD program. So space is an inherently multidisciplinary field. You cannot study it just from physics or just engineering or just biology. You need all of them together. So Italy did something smart. Instead of having 10 different universities each run a small space PhD program, they created one national program coordinated by the University of Trento that pulls together 7 universities, 6 major research institutes, and several industry partners all working together. The universities involved include Trento, IUSS Pavia, Brescia, sorry if my pronunciation is wrong because I'm not Italian, Ferrara, Palermo, Rome, Tor Vergenta, Siena, and Turin. The research institutes include ESA, that is the Italian Space Agency, INAF, the National Institute for Astrophysics, INFN, the National Institute for Nuclear Physics, INGV, the National Institute for Geophysics and Volcanology, FBK, Fondazione Bruno Kessler, and CNIT, the Telecommunications Research Consortium. And on the industry side, we have OHB Italia, Thales, Alina, Space, and Trentino Sviluppo. So this means as a PhD student in this program, you are not isolated in one lab. You are a part of a genuinely massive, interconnected national research network with access to facilities, expertise, and collaboration spanning all of Italy's space science capability. The program is organized into 8 curricula or research themes. Okay, so let me give you the full list before I dive into specifics. First one is observation of the universe. 2 is the Earth and the Sun-Earth system. 3, planetary sciences. 4 is astrobiology, life sciences and space medicine. 5th is your space sensing and instrumentation. 6th is satellite platforms, engineering and technologies. And 7th is economics, jurisprudence, and space diplomacy. And 8th, lastly, is gravitation. Each curriculum has multiple specific topic-bound scholarships, meaning the exact research project supervisor and host institution are already defined. Let me walk you through the most exciting example in each one. Okay, so now what I have done is I have created a basic understanding from the links that I've given into the web. Now it is in Italian and I do not have the conversation in English, but I've tried to grab out much of the information by converting it online. Okay, so like for example, circular 1, that is observation of the universe. This curriculum is about studying the universe itself, like stars, black holes, and fundamental physics. One project focuses on multi-wavelength observations of compact objects and transient magnetars, ultraluminous X-rays, fast radio bursts, gamma ray bursts. This is cutting-edge observational astrophysics based at IUSS Pavia. Another project supports data reduction and analysis for Euclid mission, Europe's flagship dark matter and dark energy space telescope, based at INAF's Treste Observatory. Here's one that will blow your mind. A project at the University of Brescia studies the fundamental properties of antimatter within the Alpha experiment at CERN. Yes, CERN in Switzerland. The research tests fundamental physics by comparing anti-hydrogen's energy levels to hydrogen's, probing the deepest questions about the origin of the universe. And there's a position in gamma ray astronomy with next generation observatories, ASTRI, ASTRI, and CTAO, the future of ultra high energy gamma ray observation, hunting for the most extreme particle accelerators in the cosmos. Okay, now like for example, I'm talking about the Earth and the Sun-Earth system. Now this curriculum studies how space weather and solar activities affect the Earth, combining space science with AI and data science. So one project at Fondazione Bruno Kessler develops AI foundation models to detect ionospheric anomalies and correlate them with earthquakes using data from the Lemedao or CSES satellite constellation, a joint China-Italy mission. Another at INGV Rome develops the space weather forecasting tools using the same satellite constellation, predicting disturbances that can disrupt GPS, aviation, and power grids. There's a position studying solar energetic events using ground and space telescope data, and another at the University of Siena studying lithospheric deformation, earthquakes, and volcanic activity using satellite mapping. One particular relevant project funded by ESA at the University of Florence develops AI and machine learning methods to estimate forest variables from space, directly relevant to climate change monitoring. And there's a fascinating project called Meteolium, solar storm tracking model for the moon and Mars, predicting radiation risk of future astronauts exploring these worlds. This involves simulation work and research stay at KU Leuven in Belgium. Finally, a position reserved specifically for Kenyan citizens, that is generative AI for space weather, now casting at Fondazione Bruno Kessler, combining deep learning with space physics. Talking about the curriculum 3 and 4, planetary science plus astrobiology, planetary science has a position at INAF Naples, focus on lunar analog materials, characterizing simulated lunar soil to calibrate sensors for future moon resources exploration missions. Curriculum 4, astrobiology, life sciences, and space medicine is generally fascinating if you have a biology, medicine, or bioengineering background. Two positions at the University of Rome, Tor Vergata, study bioengineering approaches to neurophysiology in space, how astronauts' brains and sensory systems adapt to microgravity, and how to protect them during long-duration missions. And a position at the University of Treste, funded by ASI, focuses on space nutrition. This project investigates how to optimize protein and energy intake to preserve astronauts' muscles and cardiovascular health during spaceflight. It builds on real ESA and ASI projects, including bed rest studies and the Nutris project conducted aboard the International Space Station itself. If you have a background in nutrition science, physiology, or medicine, this is an extraordinary opportunity to contribute to real human spaceflight research. Curriculum 5 is the space sensing and instrumentation. This is the largest curriculum with 9 standard positions plus 2 reserved for Kenyan candidates. It is heavily focused on engineering, physics, and increasingly AI. One project at CNIT in Pisa develops network distributed radars to detect space debris down to 1 centimeter, an urgent problem as mega constellation fill low Earth orbit. Multiple projects focus on particular detectors for space application at INFN in Bari and Rome and at Fondazione Bruno Kessler, developing next-generation silicon sensors for detecting X-rays and high-energy particles in space. A particularly exciting project at INAF Padua involves integrating and calibrating a hyperspectral stereo camera for a lunar rover, literally building the eyes of a robot that will explore the moon. There's a position at the University of Trento doing experimental astroparticle physics for space applications, detector development, Monte Carlo simulation, and machine learning for particle physics in low Earth orbit. And a remarkable project funded by ESA combines X-ray and gamma-ray spectroscopy, lab testing, and artificial intelligence to enable autonomous lunar resource exploration, essentially building AI-equipped rovers that can independently identify valuable minerals on the moon. The two Kenya reserve positions in this curriculum cover plasmonic antennas for infrared space detection and artificial intelligence for analyzing satellite remote sensing data, both at the intersection of cutting-edge physics and AI. Last is curriculum 6 satellite platforms engineering. The curriculum is where space science meets industry directly, with positions co-funded by major aerospace companies. One project co-funded by Thales Alenia Space develops an AI-driven decision support system for smart satellite manufacturing using process mining, machine learning, and reinforcement learning to optimize how satellites are actually built. Another with OHB Italia focuses on mechatronic systems for the LISA mission's gravitational reference system, precision engineering for one of the most ambitious space missions ever conceived, detecting gravitational waves from space. A project with Trento Sviluppo's Prom facility explores metallic additive manufacturing, 3D printing in titanium and in corner for next generation microsatellites. And there are two cybersecurity focused positions, one developing secure data sharing frameworks for distributed satellite manufacturing, and another at the University of Pisa developing post-quantum cryptography and hardware security for space systems that must survive radiation and operate reliably on missions to the moon and Mars. The two Kenya reserve positions here cover formal methods for verifying the safety of autonomous space systems and mechatronic systems and instruments for Earth observation satellites. Talking about the funding, every funded position pays an annual gross stipend of 18,345 euros. There is no tuition fee for the PhD itself beyond a small annual provincial tax right to study, which is currently not charged to doctoral students. The PhD lasts 3 years and the official course language is English throughout. And here's something important. Every single position requires a mandatory period of mobility abroad, that is minimum 6 months, at a partner institutions, which could be anywhere from CERN to NASA, affiliated labs to European partner universities. This is genuinely international PhD experience built into the structure. While the stipend may seem modest compared to some northern European salaries, remember this is Italy, where the cost of living, especially outside major cities like Trento, is very manageable, and the research opportunities, international mobility, and access to world-class facilities like CERN and ESA are extraordinary value that goes far beyond the monthly stipend. There are several special categories of reserve positions you should know about. 5 seats are reserved for candidates who already hold a scholarship funded by a foreign country, meaning if your home country government or institutions already funding you can apply specifically for those positions. 5 seats are reserved specific candidates of Kenyan nationality, and 1 seat is reserved for candidates already working in a qualified position at an academic institution or research center. Now let me walk you through the application process step by step. You need to register on the University of Trento's online application portal. If you don't have an Italian fiscal code or university account, you will just register as a guest and this gets converted on a permanent account later. Step 2, you need to pay a non-refundable application fee of 30 euros. And step 3, one curriculum out of the 8. You cannot apply to multiple curricula in one application. Step 4, within a chosen curriculum, select up to 3 topics, specific scholarships in priority order. The oral interview will specifically test your competency for the scholarship you have listed. And step 5 is you need to prepare mandatory documents. This includes a copy of your ID, passport, academic transcript, CV with any publication, English language summary of a master thesis, 3000 characters, statement of purpose explaining motivation, and research proposal, maximum 2 pages, divided into the background, rational and objectives. Submit everything by 4 p.m. Italian time, July 20th. Okay, and you'll be evaluated on 100 points. So this is it. Okay, and I'll see you in the next